And the next thing I want to do is talk about Lab 6. So this is data management. And we're actually going to label some of our own data and then store it in a way that I think is versioned. So the goal is annotate the handwriting samples we collected. Yesterday, we were supposed to collect handwriting samples just like this IM data set, but since we were tight on time, we decided not to actually do it, and we can just use the ones we collected in the spring 2019 class. And then we're going to export and version the resulting data. And then we're going to write an interface to that new data format. So first thing we want to do, open the README. Let me close all these files and go into Lab 6. I'm going to try to refresh because there's something about the text that's like rendered very fuzzily right now. Unfortunately, I think zooming in the browser kind of makes the text a little fuzzier, so I apologize for that. So in Lab 6, we want to open up the README. And there is a project page that is actually slightly different than what's in the README. So the link is actually here. So when you go to this page, which I will also post in Slack, so the login is going to be annotator at fullstackdeeplearning.com. And the password is going to be March 2019, and then we'll change it after this class. So this is not the labeling interface that I recommend. This is just the labeling interface that has the features that we need, kind of nothing we don't, and it can work for multiple people logging in and annotating. So when you make your way over to this website and you log in with annotator at fullstackdeeplearning.com, password spring 2019, we'll change it after today, you will see something like this, which I will switch over to now. So there's a notion of a labeling project, and these HITs, that stands for Human Intelligence Task. I think that's terminology left over from Amazon Mechanical Turk days. And the progress that we've made right now is 0. But there's 118 pages that we gathered in spring 2019 that I uploaded to this project. And just to take a look at what they look like, we're going to start tagging. So this is the tagging interface that we have. Let me just, OK, that's a little better. We can zoom in a little bit. We can move this around. So this is the handwriting data collection that the attendees of the previous bootcamp did. And they just had a text that they were supposed to write in their own handwriting. And then they did that over here. We collected it, scanned it in, uploaded it here. And now the task that we have is actually to annotate this data. So remember from the lecture yesterday, the first step in annotation is doing it yourself, just to understand what you actually expect the ground truth data to look like. So here, I will do a couple, and then I'll have you guys do a couple. So there's this notion of a line, which I can select by clicking or by pressing Control-1. The line is actually not a rectangle, but a polygon, because the problem that we noticed in the IM handwriting data set is that every line had to be a rectangle, meaning it was like aligned to the axes of the page. But sometimes handwriting kind of stretches and is diagonal and is not aligned to the axes of the page. So with a polygon annotation, I can create a line like this, for example, right? I'm going to delete this one. So I click on the line. And then what I'll do is I will draw a polygon around each line. So this one is roughly here. And when I've completed my polygon, I will click on this again, and it'll show up in these lines over here. I'll make another one. This one is from around here. I'll do another one. Does anyone spot any problems in my annotation yet? Do you think it's a good annotation? I think it's pretty good. But let's say if we went over to, well, let's actually finish this. So after I made the lines, that's kind of one half of the data that we need. But the second half is actually what's written inside of each line. So to do that, I can press add note right here, and then just type out what I see. So thus, a neural network is either a biological neural network, comma, made up of real biological neurons, comma, or, and so on. So I would do that. I would say, if I feel like I was done with it, I would say move to done, and I would get a new sample. So let's actually look at this new sample a tiny bit. So here we have some of the problems that a member of the audience outlined, which is that sometimes the lines kind of bleed into each other. So if I try to annotate this line, I might actually capture some parts of the other line. So I get this Y swoop in here, for example. Or it can get, oops, sorry. Over here, it gets a little rowdy. But mostly I'm still able to do it. So the challenge for me, though, is I might feel like it's a pretty easy labeling task, having done just these two things. But things are not distributed uniformly. So there might be some real messed up handwriting that kind of trails off the page somewhere in the data set. And unless I myself, as a gold standard data annotator, find them, I won't actually know what to tell my annotators to do. So were you guys able to log into this website? No? Yes? But someone was not? OK, well, if I believe the password's correct, and if people were able to log in, hopefully people are able to log in. So let's just take like 5 minutes and actually go through, click Start Tagging, and try to complete a whole thing. I will do one up here so that if you have questions, just raise your hand. I will try to spot it. But I think it's important to get a feel for how painful data annotation actually is, because a lot of people coming from an academic background just always have used a packaged up, neat data set, and they don't appreciate just how much like drudgery and work goes into it. Yeah, you'll also find that there's handwriting that you just can't read also. So a question we could have is, if you can't read some word, what should you actually do? Should you insert your best guess as to what it is? Or should you insert some kind of special token that says you couldn't read it? So here, for example, yeah, I guess it's of. Yeah, so here, there's this word, which if I didn't have the context and if I didn't have the text, like I know what text they're supposed to write. It's actually up here. But if I didn't have that, I probably wouldn't be able to read some of these words, especially this one. So in that case, foreseeing these cases, we could actually instruct the annotator to use a special token. So for example, in angle brackets unknown here in the annotation process. And so the reason we may want to pay attention to that is because if we just tell them, hey, like take your best guess, but they actually guess incorrectly, Now our training data set is probably worse off than if we had just used the unknown token, because the model is learning how to recognize words incorrectly instead of just not really learning much at all. So I have another unknown in my annotation. So looks like we're 19 human intelligence tasks have been completed. 5 were skipped, so that's kind of interesting. So we can look at the skipped ones, and this could be instructions to our annotators. Like if something is too difficult, you don't know how to do it, just skip it. And then the QA team or the data scientist can look at the data, take a look at why it was so hard to annotate, and potentially change the annotation interface or guidelines or both. So here it looks like the problem is the lines are very curvy, and just a lot of text seems painful. So here maybe the problem is they're curvy, they're kind of curving into each other, hard to read. Oh yeah, so this one, is, that's kind of what we were afraid of, text real close together, angling. So what we could choose is we could say, well, our data set doesn't have to be that complex, we could delete it. Or we can change our instructions and requeue it so that when the annotators see it again, they now have the knowledge of how to do it. Yep, this one's pretty hard too. So you guys have any questions or thoughts about this process? Question over there.
Like we face different challenges, and we tend to make some rules that this is how we need to annotate. But do we need to think in terms of, while annotating, what would actually work in the deep learning framework and what would not?
Yeah, we do, because I would say we should think about what the deep learning approach we're going to take is, but we should probably collect data that's maybe a little bit richer than that. So let's say, for example, that the deep learning approach we're going to take is only going to output page-aligned rectangles for line segmentation. But the data we collect might actually be polygons, because that's just a richer data set. If the lines are curvy, we're able to annotate it. But we can always reduce it down to the simpler way of axis-aligned rectangles. So it's nice to collect data that's a little bit beyond what you think your model is going to be capable of, because as you improve the model, you will now have the data to kind of immediately run on it versus having to re-annotate. So that's an example for this. At the same time, the more complex the annotation task, the more expensive it is. And so there's a trade-off. So I think it's worth thinking about how you're going to solve the problem with machine learning. What is the exact minimal set of data you need for that solution? And would it be not too expensive to get a little more data just in case you improve your solution later?
No, I'm talking about while deciding the rules we are going to give to the annotators. Like in this case, like we had that judgments?
Yeah, you make the question is, how do we make judgments about instructions we give to the annotators? So for example, if the lines are overlapping, do we tell them to absolutely not let the ground truth overlap, the boxes overlap? Or do we just tell them, like, make sure that each box includes all of the line that this box is about? And if it includes parts of other lines, that's OK. And my answer is, you should think about the approach, and then you should gather the data that's going to work for that approach, but hopefully also work for the next approach. That's kind of the most specific thing I can say that is still general enough.
There's an interesting question that is not related to this section, but it's more related to the labs in general, which is, if you had to rewrite this repository from scratch, what would you do differently, if anything?
For the purpose of an educational lab, or for the purpose of actually executing on this handwriting recognition project?
Let's say for the purpose of executing on the handwriting recognition project.
So there, I think problems like this highlight the fact that what makes handwriting difficult is basically the fact that lines are curved and run into each other. The academic data set that we looked at, IAM, actually doesn't have that problem, probably because the writers were instructed to make sure that the lines are neatly separated. But when we did this with you guys last time, we did not provide that instruction. And so real people in the real world, also known as you guys, generated data that looks like this, where the lines are curvy and overlapping. And so the approach that we had developed on the academic data set doesn't actually work on this one. What would work on this one is using attention. So potentially taking this whole image and not breaking it into lines, but going from this image directly to text with an attentional layer that basically goes, word, like character by character, line by line, and outputs text that way. So that's what I would do if it was a real project, is try to gather real-world data like early in the project to actually see the full range of complexity that real-world data is going to have, instead of starting with an academic data set and kind of proceeding from there. But we can talk about the specifics of like different choices also. But I think the top level thing is just that. So we have annotated some of them, 35 HITs done. So let's say we're ready at this point to download the data, and we're just going to download the completed items. So when I download the data, I get a JSON document that looks something like this. So let's just look at one line here. So this is what this annotation interface returns to me. There's content, which is the actual binary file that we annotated. This is kind of the source of our annotation. And sure enough, that's actually the file. So this is what, in the lecture yesterday, I said, in your data file, don't store the actual image. Store a pointer to where the image is stored in some object store. So here it's S3. So this object is going to live on S3, ideally forever. And we can just link to it in our data set. The annotation then is, we get a line, we get its shape, the points that make the shape, the notes. So this is supposed to have the actual annotation, and then some metadata about the image. So we can look at, just to find some annotations here. Yeah, so here we have a line. The first line is borrowing from the management literature, comma, Kaplan, and unknown classifier artificial intelligence. This is the thing it was annotated on. Just a sanity check to make sure it actually says that. OK, it does. So now we need an interface to this class. Well, we need to store this file and then have an interface to this class. So what we do is we put it in our data folder, the raw data. We should add a folder called FSDL handwriting. That's kind of our own, in-house data set. And then we simply, that JSON I downloaded, we simply put it in here. We put it in here. We add a little README. This is how we kind of generated this data, how we exported it. And then this metadata.toml file just says, OK, what is the source of this data, the source URL, the file name in this directory that the data has, and then the hash of the contents of this file. So I can manually generate that by saying sha sum 256 data raw FSDL handwriting JSON. So I get this hash right here, and I can manually put that into here. Or I can build a tool for myself that automatically does it. So when I update the file, it automatically updates the hash. And then I simply check in everything into version control. I commit it. And JSON files, I can set up git LFS to automatically store JSON files in git LFS instead of git. I just do that. So now when I git commit, new data, I have to configure my thing, so I'm not going to do it. But if I committed it, then the metadata.toml would be in my version control, and this JSON file would behind the scenes get uploaded to S3 and live there forever. So if you guys clone the repo, you'll have this, and you'll automatically download this from S3. Now let's say we go and change, like maybe as I kept talking, more people were annotating. So yeah, I think it was 24 when I downloaded. Now it's 35. So I can download again, and then I simply would update this file, and then rehash it, put the new hash in there, git commit, and that's it. So that's my dataset version. So all the images are on S3. This JSON file is not too big, but as it gets bigger and bigger, it's going to be living in S3. I don't need to worry about it slowing down my Git repo. And then this is really the version of the data that I'm running on. And of course, as we run experiments in our run experiment harness, I believe it records the version of the data set as part of what's logged into weights and biases. And if it doesn't, we can easily add that. So that's like the quick and dirty way to version data. And that's mostly what we need most of the time. You guys have questions in the 2 minutes remaining?
Two related questions. So this text recognizer repo, right? So this is like an example of an end product or an end code base when something is in production or near production. So two related questions. The first is, what would be typical timeline for developing this type of repository, and how much time did it take you to build it? And then the second question is, do you have guidelines on how to build up to something like this from the ground up? So what sequence of steps would you take when you're implementing this code base? What would you do first?
Well, I think it's just useful to have a mental model and an expectation for yourself that you should be able to run a single command that goes from the rawest version of your data all the way to the trained model, and it happens the exact same way every time you run it. So if you have that expectation for yourself, then I think there's choices that you're not going to make. Like you're not going to have notebooks involved in the training process, for example. And the choices that you do make will resemble kind of this, where the data set is versioned, there's kind of a nice run experiment command or something like it that is able to run the whole experiment. You'll find that it's useful to separate your network code from your, for example, dataset code. And you'll find that different networks can slot into the same model, so maybe that's useful to separate too. So I think learning from this lab and then setting just a high bar for yourself that you got to be able to run the whole thing from scratch in one command.
And then how much work goes into building something like this, and how much time did it take you to build it, let's say?
Like a surprising amount of work, I would say, because in a notebook, you can get something working, and you will train a model, And you might in fact be able to train another model. But to train that exact model that you trained the first time, if you want to train that exact model again, you'll find that that is actually very hard to instrument all the code around. So yeah, the difficulty of like training machine learning models is a little bit deceptive, because when you got a single notebook going, it feels pretty easy because, yeah, you can run some cells, you get a model. But the challenge is in getting that same exact model another time, like in a week or in a month. So in order to do that, you'll have to write the dataset versioning and all this other stuff. So I think it's more work than it seems. And for this specific code base, I would estimate we spent over the last year, it's got to be over, I'd say like 50 hours or so.
Yeah, it seems right. Two other related questions. So related to each other, not to the last question. So there's a lot of work in updating things, like updating the JSON file and the hash. And so is there a better, more automatic way to do this, especially in the context where you have more training data that's coming in after the model has been deployed? So how do you like make that process of incorporating new data into this efficient?
So you could actually skip this metadata file. It's kind of nice for me to just be able to see it. But in fact, Git LFS does this exact thing behind the scenes. So if we actually open the, well, I'm not actually sure how to look at that. But if you check out a clean version of this repository and you like actually cat, for example, the JSON file, you'll see that it's not the JSON content. It's the content that basically looks like this. It says the S3 key is this, the file name is this, and the hash is this. And so we can skip this step, so we don't have to do that. So we can just update the data and git commit it, and behind the scenes, it'll do exactly this. So that's one answer. The second answer is that's where it might pay to actually use a dataset versioning solution like DVC or something like that, which basically does this in a single command, right? So I would say DVC add fsdl handwriting.json, and once again, behind the scenes, it would record this kind of info for me. But I think Git LFS, you can go a pretty long way.
Do you have any strategies for making sure that the annotators follow the guidelines that you set? So like, let's say that you have good rules, making sure that all of your annotators are actually following all of them and identifying people who are not doing it and sort of making sure that they get kicked off the project. Yeah,
so that's where it pays to actually use a service company or at least software that they provide. So once again, I don't endorse this software. It seems pretty rudimentary. But other companies provide software without making you pay for their labor. That's much nicer. So it gives you like estimates of how, it like tracks the speed of annotators. If there's a QA layer, it'll track annotator accuracy. And so you don't want to reinvent that wheel. You just want to use software that exists. And ideally, you don't have to do any of it. You just have enough money to actually pay someone to do it. But at least don't reinvent the software. Oh, and also I think it's very important to let annotators know that they can ping you if they have any questions. So if they have a question about how to annotate something, it's better that they don't annotate it at all and just like click on some flag that alerts you. And then you can set a time and review all the hard cases together.
Do you tag data that comes in post-production any differently than original data? Like, should that data be treated differently in any way than data that was used for the original model training?
I think that's a good question, and I don't think it should be treated differently, but perhaps it should be treated, let me see if I can open this JSON file again. Where was it? So for example, here, I could have a source, right? And so the source could be March 2019 bootcamp for this one. But if another thing came in, I could say, user data, ID, whatever, ID of the user. So I could record something in my dataset file about where that specific item came from. That's a very good idea because then you can always go back, like maybe something went wrong, right? And so then you can narrow it down to like user data that was generated between, I think it records, yeah, there we go. So it records the Unix time of when it was done, when it was actually annotated. We can also record when it was actually generated as the input data. So maybe something went wrong in your system, and like on this specific day, you should just throw out all the data. So, good question.
Quick question, so your data file, you always have one data file that you just keep versioning on every single type of run?
Not necessarily. So you could, for example, have, so we could call this FSDL handwriting March 2019, and then, let me see. Yeah, there we go. So, and then let's say the data that we collected today would be November 2019. And then in my metadata, I would actually say source, and then whatever this is. So this is another reason to use this metadata format, is because the dataset class actually knows what data to load by first loading this. So in the dataset class, what it does is it first loads this metadata, and then that tells it what data to load. And so yeah, if I add more data, then that's pretty easy. I just add it here, and then I add it as another source in my metadata. That's how I would do it. You could have, once again, also skip this step and just say, like, whatever's in this folder, and just read all of that.
Great. Maybe let's wrap up there.
All right. Thank you. It's lunchtime.